Broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Thanks for joining us for another Best Practices webinar series from 7Signal. I'm Don Cook, and with me this week is Jim Vajda.
Hey, Don.
Good morning, sir. And Jim and I are both in Ohio, though I'm up in Cleveland at headquarters, and Jim is down in Cincinnati today. And if you folks don't mind letting us know where you're logging in from and whether or not you're working from home or remote, that'd be great. I see some of them are already starting to come in a little bit. Olivier, who's always first, though I feel like he's been missing the last 2 weeks. If I were to pick on him, he's logging in from Vancouver, so welcome back. We've got Chris in Surrey, UK.
Oh, really good cycling in Surrey, Box Hill, and some other nice roads out there. Beautiful area.
Chris, can you confirm or deny these allegations? Let's see, we've got Lewis working from home in New Jersey, working from home in South Africa with Abu. David is in Mississippi working from home. A lot of people working from home, it looks like. Frank in Grand Rapids. Yeah, Chris says it's really hilly there. Jim working from home in Minnesota. Anders is in Sweden. Welcome back. Working from home is Joe in Nebraska. Chris, yeah, he says again. He said loads of cycling routes there. So I guess confirmed, Jim. Have you been there?
Or I have.
Oh,
yeah, I was out for Wi-Fi design day in November, and I had a free day where I rented a bike and did Box Hill and White Down Lane, and there was another really big climb I did.
Oh, very cool.
In the English rain. The real British experience.
You got the full experience.
It was awesome, actually.
Very cool. We've got Dave with Planet Bingo. Welcome in Arizona, New Delhi with Sarab. Paul from Southeast PA. Welcome back. Chip in Los Angeles. Kent, Ohio with Dave. Awesome. Thanks for giving me that info, guys, and girls. And for those of you who are shy, don't be shy. Go ahead and let us know where you're logging in from. We've got quite a few of you on the line today. We're going to go ahead and get started. We've got a great topic for you, as we always do. We're going to do a deep dive. And when I say we, I mean Jim Vajda is going to give us a deep dive into DFS today. So if you're looking for some great content, you're in the right place for that. We've got a couple slides to walk through with you today before we hand the controls over to Mr. Vajda. These sessions are certified through CWMP. So for those of you who are getting your certifications, I've got my trusty book here with me today. I was pulling one of our questions out of a book today that you're going to see here in a second. Test your knowledge a little bit before we get started. If you're looking for product information from 7Signal, maybe you signed up for this webinar just assuming that we're going to go into our products and services today. We don't do that on these webinars. You can go to go.7signal.com/tour and get a full product tour there. We do those every Friday at noon Eastern time. And if you'd like to have a copy of this webinar, we always post our webinars on YouTube, and we always share the slides on Twitter. So you got to follow us on Twitter and subscribe to our YouTube channel, and that'll make things easy for you. We do have a promotion, so for those of you who are familiar with our Mobileye product, we are giving away 50 Mobileye licenses for 50 days to help you out with your remote employees and other issues that you may be experiencing with your device connectivity. So I'll drop this link into the chat in just a few minutes, but go.7signal.com/50 for 50. Just a little bit about us. 7Signal started in 2007 in Helsinki, Finland, and moved to the US about 3.5 years after that. We've hit a lot of major milestones along the way. We're up to 1 billion data points we monitor on a daily basis. We're on a lot of customer networks. We're on over 5 million devices around the world. So we're pulling a lot of numbers. Over 200 customers around the world, over 30 partners. We are GDPR compliant for those of you who are logging in from the UK and EU. Privacy is paramount for us. Not only our technology stack continues to stay relevant, but we stay up to date with all of the privacy metrics that we have to. We've got 14 patents, so what you see from 7Signal, you are only going to see from 7Signal. And we're in this market because connectivity enhances the digital experience, and that's why we're here. Our solutions give unparalleled visibility into the end user experience and gets our end users root cause information on why there are connectivity issues. Because we have a unique outside-in approach, which I'll get to in just a few minutes. We offer two solutions right now, our Mobileye and our Sapphire Eye modules. They are all part of the 7-signal platform. And what we're looking for are what we call the top 7 Wi-Fi problems. And these present themselves differently, as everyone on this call knows. The end user knows that the Wi-Fi is slow, or it's intermittent, or they can't connect. Well, there's a reason for that, and we find those reasons. Things like congestion and coverage and interference, network services, adapter and driver combination issues. How we're doing that is we're running active and passive tests on the network and on the devices for things like packet loss and latency and jitter, MOS scores, looking at the spectrum for interference and full packet capture, things you just can't get from other providers out there. If you look at this from a traditional infrastructure standpoint, a lot of you who are not 7-signal customers rely on vendor diagnostics that gather information from the inside out, that live on the controllers and the firewall, on the servers. Some great solutions out there, SolarWinds, AppNeta, the list goes on and on. Your AP vendors, Citrix, Cisco, Aruba, Mist, Extreme, etc., giving you data, what's going on with those access points. But where we live with Mobileye is on those devices, looking at the end user experience and telling you exactly why those devices aren't able to connect, information that you just can't get from anyone else. And the same goes for our Sapphire Eye, our perfect client or sensor that lives up in the rafters with the access points, looking at that full spectrum and looking for service level quality, looking into the air to see what's going on there. Again, things you just can't get from other providers out there. So our modules side by side, what you'll gravitate toward, the colors at the bottom, these are the problems that each module fixes. Together, they fix all 7 Wi-Fi problems. Separately, they do a great deal of coverage. Mobileye, of course, because it's the solution that installs on the device, any Mac, Android, or mini PC. So we have a lot of customers out there who are more and more using mini PCs to attach to non-traditional IoT devices, forklifts, robotics, etc., Linux devices, so they can get some real visibility into those roaming journeys on those machines. So adapter driver combinations, roaming issues, different types of interference than a Sapphire Eye would. Mobileye is going to look at more co-channel and adjacent channel interference, where Sapphire is going to come in because it has a spectrum analyzer on it. You're going to get radio frequency co-channel interference in a different way than Mobileye would look at it. Also, more in-depth look into network services and wireless LAN configuration. So those are products side by side. Everything reports up into the cloud, where all the numbers are crunched and reported out to you through our dashboards. And we have a full SaaS model, so no hardware pricing separately. Really, really easy to do business with us. So before we get going, I promised a trivia question. We're going to roll that out here. We're going to test our knowledge before we get going and see how everybody does. And I just launched our poll, or what they call a poll, but it's actually a trivia question. So I'm able to go to GoToWebinar after the webinar and see who answered this properly or correctly first. So for those of you, for that individual that does, I've got some 7-signal swag for you. So take a minute and answer this question: in which bands might radar be detected on your wireless LAN? So there are two bands in particular that you'll be able to detect radar. So I'll give that another couple seconds here. It looks like we're slowing down on responses here, teetering back and forth. And Jim, I know you can see these responses in real time too. So let's see how everybody did. And I'm going to share the results.
Not bad.
Yeah, not bad indeed. So
Uni
the
2A and Uni 2C are the correct answers.
yes, indeed. All right, so I'm going to hide those results, Jim, and I'm going to give you control, and we're going to get to the show.
Perfect. Sounds good.
All right, you should have the ball.
Yep. And okay, you should see the About Me slide.
I do.
All right, thanks, Don. Well, I am Jim Vajda. I'm the Director of Global Wi-Fi Solutions here at 7 Signal. I'm a CWNE and CCNP Wireless, CCNP Enterprise with wireless specialties now. I have experience in wireless network engineering in healthcare, education, nonprofit, MSP, and a few other verticals. You can follow me on Twitter at Jim Vajda, and I have a blog at framebyframewifi.net, and I am a fairly newly minted amateur radio enthusiast. So there's my call sign there, Kilo Echo 8 Oscar Kilo Victor. And Don, you can key me up anytime you'd like.
You're playing a lot of polkas, or with?
Anyway, on with the show. So today we're going to talk about DFS, which is dynamic frequency selection. And what it does is it allows Wi-Fi clients in the 5 gigahertz band and APs to use spectrum that already has existing users in it. So non-Wi-Fi users of that RF spectrum that a regulator would call an incumbent, right? They're already there and they have priority access to the spectrum. So in the DFS bands, as we call them, some of those include weather radar. That's the most commonly identified DFS user. Military radar, which can be airborne or shipborne. Those airborne radars can be problematic, and a lot more, including non-radar systems, communication systems, and other things that are less well known, but also are incumbent users of this spectrum. So what DFS does is it allows Wi-Fi to operate in this spectrum. Wi-Fi is an unlicensed spectrum user, and it gives us a protocol that makes sure that we're not interfering with the incumbents there, and will vacate those channels if an incumbent is discovered. So that's what DFS is, and why even bother trying to share spectrum with the military, the U.S. Navy, the weather radar at the airport? Well, it's because this is what the spectrum allocation looks like here in the U.S. There's just not very much or any unused spectrum, and so what regulators have been doing for the last decade or so is looking at kind of novel and smart ways to share spectrum between different users, because the Navy isn't a big spectrum user here in Ohio, so we should be able to run APs where that spectrum is available, for instance. And it's important that to understand that the rules for DFS are set by the spectrum regulators, the RF spectrum regulators in each country or domain. And then what we get from the IEEE, from the standard, is sort of a protocol that helps us obey those rules and make sure that we're compliant. So, but the rules themselves are come down from these regulatory bodies, and they're actually not specific to Wi-Fi. They're talking about unlicensed use in the DFS band, but of course we'll just talk about Wi-Fi today. So here's a look at the 5 gigahertz spectrum where DFS is sometimes required. You can see in these blue areas, that's where DFS is required. So 2/3 of the channels available in the 5 gigahertz band require DFS operation. So another way to think about it is if you're not using the DFS channels, you're only using 1/3 of the available capacity in the 5 gigahertz band. And if you have a high density network or a real performance oriented network, that's a big deal because you're leaving capacity on the table, and you probably have to accept more co-channel interference, since if you take out the DFS channels, you only have 9 non-DFS channels to work with in your channel plan. So we want to use DFS channels if we can, but we just need to understand what the limitations and requirements are for using DFS. And this is a nice chart that you can get from the WLAN Pros website. It shows the different DFS rules and different regulatory domains, transmit power, and so on and so forth. So why is this important? Why do we need to be so sensitive to the incumbents? Well, again, some of those are military radar. Maybe it's my Cold War childhood, but having a military radar go blind is kind of a scary thought. Also, terminal Doppler weather radar. Those operate on channels 120 and 124, and they're used for detecting wind shear at airports. In fact, that's a photo there of a TDWR at an airport. The next time you fly, whenever that is, take a look out the window and you might see one of these. Really important safety equipment at radar at airports. And so because there are these really important operators already present in the band, it's really important that we're not operating on channels that they are. So terminal Doppler weather radar is used to detect localized wind shear at an airport. The normal Doppler weather radars that say the National Weather Service operates don't have the resolution that airports need to see localized close to ground wind shear. And that's a really important function because if a crosswind, if wind shear is really heavy, you could get a situation like this where you get an extremely unsafe landing. I don't think anybody wants that. So if your AP is operating on a channel near an airport that a terminal Doppler weather radar is using, that weather radar could become unusable, and we've got a safety hazard now. So nobody wants that to happen. A couple of amendments to the 802.11 standard that are relevant here. 802.11d, the D, you can think domain to remember that one. That sets up regulatory compliance with other countries outside of the couple that were sort of baked into the 802.11 standard at first. So that allows APs to kind of assume the spectrum rules for the different domains that they're going to operate in. 802.11h was the amendment that allowed us to start operating on DFS channels and set up the protocol for allowing that to happen. And so usually, when you buy an AP, it comes hard-coded with a regulatory domain. So I'm out here in Ohio in the middle of the US. I'm working on Wi-Fi networks here in Ohio. if I go to a AP vendor, they'll just sell me, without even asking, they'll sell me APs that are hard coded for the US domains. So if I were to, spec an AP that was, that had the SKU for an Australian domain, for instance, pretty sure, my account manager would say, are you sure you want that? Because, those you're only supposed to use in Australia. So usually what you buy out of the box, the manufacturer has hard-coded to be compliant with the spectrum rules of the country that you're operating in. There are some APs that have a configurable regulatory domain. Sometimes those are called universal APs. And sometimes manufacturers that sell worldwide have in the past left their APs sort of unconfigured, and then when you get it out of the box, you have to select the right country that you're operating in. Be careful with those. That's where, a wrong answer or a misconfiguration with one of those could set you up to be violating those rules, which we don't want to do. So let's dive into DFS operation and talk about, the nitty-gritty of how the protocol works. The first thing that happens when an AP wants to operate on a DFS channel is the channel availability check. And so we need to make sure that there aren't any incumbents present. And the way we do that is the AP goes silent for 60 seconds when it starts operating on a channel, and it's just listening, and it wants to see if there are any signatures of radar or other incumbents on the spectrum before it starts to transmit. So if you have a AP that's switching channels with clients on it, it will stop transmitting for a full minute if it's switched to a DFS channel. So that can be pretty disruptive. And in the EU, if you're switching to channels 120 to 128, there is a 10-minute silent period required. So I'm curious if any of our listeners in the EU, if they're even using those channels, because that's a pretty disruptive or onerous requirement in my mind. But again, 120 and 128, that's where terminal Doppler weather radar operates. So the spectrum regulator in the EU wants to be extra careful that there's no interference there. And so if the AP does not detect an incumbent, it can start operating there. And in DFS language, the AP is considered a master device, and clients are considered slave devices. And all that means is the AP is responsible for monitoring and detection of radar and other incumbents. And then the clients just obey whatever the AP is doing. If the AP needs to change channels, they have to go along with them. And they cannot transmit on a DFS channel until they've heard an AP transmitting there as well, which has an important effect on active probing. So after the channel availability check, there is in-service monitoring. So the AP, while it's operating on a DFS channel, it's continuously listening to see if an incumbent might show up, right? So maybe there aren't weather radars present, but an airborne military radar comes by. So we need to have that continuous monitoring going on. And when an event is detected, the AP, it has to stop using the channel and change channels very, very quickly. So it can change channels immediately, which is bad news for all its associated clients, right? They're just all of a sudden they have no AP to talk to and they don't know where it went, and then they have to sort of panic roam to find somewhere else to go. Or the AP can more gracefully change channels and inform clients of the new channel it's going to through a channel switch announcement. So let's look at a channel switch announcement, or CSA. So these are either action frames, or this can be included in a beacon frame as a unique information element. And it's actually a very, very simple frame. So here's the action frame, and it's really just got three fields: the channel switch mode, the new channel number, and the channel switch count. So this is just an AP saying, I've had a DFS event and I'm about to go to channel 40, and it's letting clients know it's going to channel 40 and get ready. Now, client behavior in response to this is varied. It's really up to the client to decide what to do, and you'll see a lot of diversity in behavior here. Some clients may roam immediately to a different AP when they get a channel switch announcement. They may say, oh, I don't want to deal with this. I know there are other APs around here. I'll just roam somewhere else right now. Some clients may follow the AP. Okay, you're going to channel 40 and it's happening very quickly, and I know you're going to maintain my association, so I'll just follow you. And some clients just simply may not respond at all. They may not have any kind of logic behind responding to a channel switch announcement, and they just panic roam after the AP changes channels. So it's really a mixed bag. There's also extended channel switch announcement. This is the channel switch. We'll look at that next, but this is the channel switch announcement as a beacon frame information element. This one's a little different. It has a channel switch count of 10. This is kind of graceful. It's actually sort of a countdown. So each beacon will drop that number by 1. And so what this one is saying is actually in 10 beacon intervals, which is roughly 1 second, I'm going to switch channels. So it gives clients, a period to kind of make sure they're aware of it, right? Because we're doing 10 channel switch announcements, so they get a chance to become aware that we're going to switch channels and make a decision about what they're going to do. So that potentially could be a little bit more graceful. I'll also mention here the channel switch mode. So it's either a 0 or 1. A 0 means clients can continue to transmit until we've switched channels. So if there are data frames being buffered back that need to get transmitted, they can get transmitted before the channel switch. If it's a 1, clients have to be completely silent and cannot transmit on the channel at all. But the AP will maintain their association. So again, pretty disruptive for real-time applications for this to occur. So there's another channel switch announcement format. The extended channel switch announcement also can be a unique action frame or packaged up in a beacon. But this has all the same fields, except it adds the new operating class, so the new channel that we're going to. And you can see here Wireshark hasn't decoded the hex, but the operating class there is 3. And all that's saying is, according to the 802.11 standard for operating classes, I'm going to this subset of channels, and I'm going to use this channel width. So this is kind of nice. So if we look at the 802.11 standard, they've got a long table of what the different operating classes are. But operating class 3 in this case is the Uni 3 channels, 149 through 161, with 20 megahertz channel width. So that makes roaming easier. I only have, you know, I know what channel to expect you on, and I know the channel width that you're going to use, so I'm already ready to start transmitting as soon as the channel switch happens. Okay, so after the AP changes channels, there's a required non-occupancy period, which by rule says the AP can't go back to that DFS channel where an event occurred for at least 30 minutes. And if it does want to go back, it still has to recognize that 60-second silent period on the DFS channel before it can start transmitting again. So the whole kind of flow, if you will, starts at the top with the channel availability check, where we're checking to see if we can use the channel, if there's any incumbents present. In-service monitoring, if there's a detection, then we can do a channel switch announcement, and then we cannot go back until the non-occupancy period expires. So there's a lot of ifs, ands, or buts that we went through when we talked about that. And so, you know, there's a lot of uncertainty and a lot of details that are not well understood or documented. So, you know, what the APs actually do after changing channels. You know, the FCC doesn't care where the AP goes, what channel it uses, as long as it leaves the channel that the incumbent's on. That's what the rules say. And now it's up to the IEEE and the AP vendors to kind of take it from there. And so it's not very well standardized as to what channel an AP might change to after a DFS event. So, you know, sometimes RRM will play a role, and you might see different behavior if you have statically assigned channels. Certainly, there are differences between vendors and what they have their APs do. AP models sometimes behave differently, and even different code versions can affect the logic that APs operate with a DFS event. So, and I've seen all of these possibilities with different APs, but sometimes an AP will go to that non-DFS channel and never go back. It'll just say, oh, there was a DFS event. I can't operate here. I found a non-DFS channel, and I'll just stay here forever until somebody comes and switches me back. Sometimes that AP will try to return to the DFS channel after the non-occupancy period expires. Sometimes it might move from one DFS channel to another. And to do that, again, we've got that 60-second silent period, which, you know, very disruptive for any associated clients. And, you know, that might be a reason some clients decide to roam to a different AP. If they see an AP moving to a DFS channel, which will have to mean that AP has that 60-second silent period, clients might say, oh, no, I don't want to deal with that. Let me go to some other AP where I won't get that disruption. And then I think, you know, one of the worst case scenarios, and I have seen this, is APs sort of get stuck in a loop. I've seen this with statically assigned channels, where if you statically assign an AP to a DFS channel and it has a DFS event, it will go to a non-DFS channel, sort of a randomly chosen one as far as I can tell. And then as soon as the non-occupancy period expires, it goes back to that original DFS channel. Once again, has a DFS event almost immediately, and then goes back to a non-DFS channel. And then it starts the whole process over again. So every 30 minutes, we're changing channels. We've got a 60-second silent period interruption, and we're sort of stuck in this loop of DFS and non-DFS channel switching. Very, very disruptive, and certainly a scenario that you want to avoid. So a lot of uncertainty here, unfortunately. The good news is there are some people trying to document how APs, specific APs, respond to DFS events and what their logic is. You can go to the dfsproject.com to see that, and you can get packet captures, and they've got some cool spectrum analysis that shows DFS occurring and you know, seeing what happens in the packets at the same time. And you can contribute there too if you've got some research you've done into the behavior of certain AP models to DFS events. That's a really handy resource. So it's important to obey the rules, as I've said a couple times here. Here in the US, the FCC takes protecting incumbents, particularly terminal Doppler weather radar, very seriously. They have a web page where they list, you know, they name and shame all the people that they and companies that have violated these rules. They have a law enforcement capability. So, you know, obey the rules and don't try to get cute with, you know, changing the regulatory domain and disabling DFS like some older APs with older code allow you to do. You don't want to show up on this list, and you certainly don't want to have FCC enforcement agents knocking on your door. This is a cool web page, though, just to look through and see some of these items that have occurred. And another thing the FCC put out last year wasn't about operators as much as it had this interesting clause about manufacturers of APs. And I just thought it was interesting, just putting manufacturers on notice that they cannot allow you know, allow third-party software modification that would allow the device to operate in a manner inconsistent with these rules. So, you know, particularly in the point-to-point outdoor domain, that's where you've seen a lot of people breaking the rules. Of course, outdoor APs have more reach than indoor APs. And if you're using a DFS channel for point-to-point link, it's so disruptive for that link to go down because of a DFS event. So, you know, some of those operators would love to just not use DFS, but not a good idea. And more recently, unfortunately, Cisco had a problem with the code for some of their APs. This is in the 8.5 train, and it affects the 2800 and 3800 platforms. And unfortunately, the DFS radar detection there is broken, and there's some scenarios where an AP may not vacate a channel where an incumbent is present. So that's very serious. I would say if you're a Cisco customer, look this up. It's field notice 70577, and just make sure you're not at risk here. You know, the last sentence here: customers who operate APs with the software might be operating in violation of regulatory requirements. You know, they did leave out the part about manufacturers also having some responsibility, but certainly I'm sure they're aware of that, and this motivated their you know, action here to get this addressed. They do have code out that fixes this, so check that out if you've got those APs. So some of the problems with DFS that you should be aware of. You know, the overall concern here is uncertainty. there's no way to know if an incumbent is present or not, and what channels they're using, and are they temporary or are they permanent, and exactly how your APs will respond is also largely undocumented. False positives are very common, and a couple of reasons for false positive DFS events. First, it takes a long time, at least here in the US, for the FCC to certify an access point for operation in the DFS bands. And the AP, that can hold up releasing new AP models and new hardware. And you know, vendors don't want to be the last one to the party with their new, you know, shiny new Wi-Fi 6 AP. So to make sure they pass that FCC certification, you know, they have an incentive to make those radios hypersensitive, if you will, to DFS events, because the last thing they want to have happen is that certification fail, go and then have to start all over again and wait 6 months, maybe longer, before they can get through certification again. Another common cause of false positives are client transmissions are sometimes detected as radar. And you know, the reasons for that is it's really, really hard to detect a radar hit on an 802.11 radio. It's extremely brief. They're almost impossible to catch with a spectrum analyzer. And the AP, you know, is transmitting and listening to a bunch of Wi-Fi clients at the same time that it's trying to do this. So it's very, very difficult. And, you know, one of the ways that you can tell if clients are a likely cause of false positives is just, you know, take note of when DFS events are occurring. If they're sort of spiking in the middle of the day, you know, in an office that fills up with clients during the day and then empties out at night, it's probably those clients that are tripping DFS false positives. If your DFS events are kind of a constant, it's probably not clients that are causing that. Another problem here that I talked about is for clients to discover APs on a DFS channel, they can't use active probing, which is a really fast way to discover an AP. When you're probing, a client switches to a channel, immediately transmits a probe request. The AP responds with a probe response, and in 10 to 20 milliseconds, that client has discovered the AP on that channel. That's not a lot of time, but if you've got 25 5 gigahertz channels to scan, that adds up. And while you're scanning, you're not transmitting data frames. You're buffering frames. Maybe there's some packet loss. So active scanning is preferred, but remember, clients have to follow APs. They can't transmit first on the channel. So they can't actively probe on a channel until they've heard a beacon from a AP. So that's called passive scanning, where the client just goes to the channel and listens until it hears an AP transmission, and then it can start transmitting. Can't just blindly transmit a probe request like other channels. So passive scanning, though, if we're waiting for beacons, can take about 100 milliseconds. So that could be 10 times as long on every single channel to discover an AP. And again, while we're in that discovery process, we're not transmitting, we're not receiving frames. And for real-time applications like voice, that's really disruptive. So some VoIP handset manufacturers recommend against using DFS channels for this specific reason. And we talked about it, but the channel switch and silent period certainly can be very disruptive in a lot of different ways. Now, with that said, I do have a little crusade about using DFS channels around airports. This is actually a look at the 5 gigahertz spectrum, well, the Wi-Fi scan results from inside the busiest airport in the world, ATL in Atlanta. And you can see they're using a bunch of DFS channels, right? Here and so don't be afraid. You know, sometimes we hear, I can't use DFS channels because I'm close to an airport. That's probably not true. It probably means there's, you know, a couple channels that are unavailable, right? But it's just 120, 124, and 128 where terminal Doppler weather radar operates. And even here at the airport, they're using 124 and 128. So just, you know, see what's out there and don't be afraid to use it, because there's a lot of capacity there that's available that you know, it would hate to go to waste. One more thing about airports. Here is my local terminal Doppler weather radar at the airport local to me in Cincinnati, and you can see across the 5 gigahertz band, it's just this tiny little red column where it's operating. I think that's around channel 124. So all the other spectrum I can operate in. A couple design considerations. You know, use the APs that were approved for the country you're the Wi-Fi network is going to operate in, and you won't have FCC enforcement officers showing up at your door. Understand the rules, and to kind of address some of the uncertainty, if you have time, test each DFS channel you want to use. Put an AP on each DFS channel, and just, you know, take note of DFS events that occur on those channels to see what you can use and what's not available. Try to understand how your APs will handle DFS events. You know, the DFS project can help with that. And then understand the impact it can have on roaming. And if you have, you know, VoIP and real-time video on the network, take that into consideration. One more thing I want to talk about in terms of shared spectrum is what's happening in 6 gigahertz. This is the new 1200 megahertz of unlicensed spectrum we have access to here in the US, and other countries are working on their rules for this band as well. This is what Wi-Fi 6E will use. And what's nice is I think that we've learned from a lot of the challenges that DFS introduced. And we're not going to make the radios in 6 gigahertz because there are incumbents. We're not going to make the radios responsible for detecting the incumbents. There's actually going to be a centralized system. It's just aware of all the transmitters, all the existing incumbents in the band, called the Automated Frequency Control System. And it's, you know, a public database that you can query and say, okay, I'm going to operate here in Cincinnati, Ohio. At, you know, this is my Latin launch, for instance. What channels can I use? The database will say, oh, you can use this subset of channels, and you can't use this channel, these channels, and off you go, which is wonderful. Now we don't have to worry about false positives. We have certainty. We don't have to worry about a B-52 flying overhead and wrecking the whole, you know, Wi-Fi network. You know, it's really an improvement, and I'm looking forward to that. So with that, I think, Don, I think we can finish up the formal portion and maybe do some Q&A.
All right, that sounds good. Thanks, Jim. Well done. I've got 11:48 here local time, so maybe we'll take 2 or 3 questions if we've got the time to do it, depending on how long the response times are. Let's see what we've got. And Jim, your camera blacked out on us. I don't know, maybe 5 minutes ago or so. If you want to try and
yeah.
So I'll go, and I think you answered this one during your last one of your last few slides, but I'll ask it anyway here for for Manish. Do clients send probe requests to DFS channels? He sent this early on in the presentation.
They cannot send a probe until they've heard an AP transmitting there. So it's not that they can only passively scan. They can't actively probe, but that probe can't happen until they've heard an AP. So in effect, it's passive scanning.
Thank you, Jim. Thanks for the question, Manish. Question here from Thomas. Is the NOP period the same globally, or does it differ per region?
Yeah, that's a good question. I believe it's the same globally, but I'm certainly more familiar with the US rules than elsewhere.
All right, thank you. Thanks for the question, Thomas. Next question from Daniel here. How far can a radar be detected by an AP? We don't use Uni 2 channels to avoid airport radars, but I think we are far enough, 10 miles, to detect them.
Yeah, good question. I think it has to some degree do with the topology of the area. You know, if you've got line of sight and it's flat, it's going to be a lot farther than if it's hilly and wooded and you're down in a valley or something like that. So it's going to be very variable. But those, the radars and APs are extremely sensitive to any transmission from one or the other. So, I would just test it where you are and look and see which channels your APs have DFS events on and which they don't.
Thanks, Jim. Thanks for the question. Next one here is from David. Can you tell from the captured packets if the AP has DFS enabled?
That's a good question. So there are some 802.11h and 802.11d specific information elements in a beacon. So you should see information elements for, I'm thinking of 802.11h, there's a transmit power control, which shows like an offset and the maximum transmit power allowed, and there's 802.11d will show the country code that you're operating in. If you don't see those, that would kind of start to make me suspicious about if DFS is enabled or not.
Thanks, Jim, and thanks for the question, David. Probably got time for two more here. And I've got a lot of requests for the slides. Apparently, Jim, folks are loving those slides. So for those of you who are interested in those, you can either follow us on Twitter @7signal, or if you don't have a Twitter account, just simply respond to any of the numerous emails you get from me, and I'll get you a copy of those slides. Next question is from Olivier. Are radar signal generators used for layer 2 DOS disruption or hijacking attacks?
Well, they certainly could be. There's a new one from Wi-Fi Metrics that you can use to test DFS response, and I know some of the people involved in the DFS project are using that to document what APs do in response to DFS events. I don't know if I guess they could be used for a denial of service attack. I think any kind of signal generator that can use those frequencies would work as well. And I don't know, how effective an attack that would be compared to some of the other options that a malicious actor might have, but the possibility's there.
Mm-hmm. Thanks, Jim, and thanks for the question, Olivier. Next question here from Jason. When clients roam, can WLC help with things like caching from AP to AP roam?
Yeah, so all your key caching capabilities like opportunistic key caching, and 802.11r fast transition, all that stuff still comes into play. And the other thing is that if the AP switches channels and the clients follow it, it's not dumping its keys or association table. So if the clients go with it, they're not reassociating. They've already got an association to that AP.
All right, let's go with one more question here. One last question from David, and I've got a couple other here, and we'll take these offline and respond to them. It says, we have DFS enabled on the center APs in the hospital. Would this be a good practice, or should we enable all the APs on the floor?
Yeah, that's a good question. I've dealt with that exact scenario in a hospital WLAN, where I use DFS channels more frequently in the basement and towards the center of the building, where it was less likely for the RF to escape the building or for radar signals to get into those areas of the building. So I think that's a good idea. I also think it's smart to sort of salt and pepper your DFS and non-DFS channels in together, just in case there's a client that does not support DFS channels. That's more rare, but unfortunately in healthcare, there's a lot of really ancient clients out there. So if you have overlapping channels and one's DFS and one is a non-DFS channel, then you can always service those clients. But I do think that's a good idea. Is if you're really concerned about DFS events, keep those APs operating on those channels closer to the center of the building.
All right, thanks, Jim. We'll take that one as the last question. Jim, thank you very much. Great presentation as usual. Everybody, thanks for the attentiveness today. Thanks for staying with us the entire time. We ran a little bit over. We'll see you all next week. Thanks for the follows. I've just followed back about 20 of you that are new followers for us. So keep those coming, and we'll see you all next week. Thanks.
Thanks, guys. Thanks, Don.